and a PhD from Oregon State and postdoctorate from Brandeis. So those are wonderful credentials, and we appreciate that. And now he's well-traveled, extremely well-traveled, and he is a naturalist, and he calls himself a naturalist and a scribe, right? Yes. And he's a consultant for chemistry groups, natural resources, etc. So, Lenny, Dr. Lenny, please come forward.
Okay. She says scribe and she asks a question, and I can pull out my book and say what scribes do. I spend lots of time doodling. And the doodles, well, some doodles are good, some doodles aren't good, but they all make sense in some mysterious way. This is not going to be a talk that shows you lots of pictures of the skies. You've all seen pictures of the skies. How many people have ever taken a chemistry course?
What?
A chemistry course. Okay, now how many of you have taken a college chemistry course? All right? In the last 5 years? Okay. So we have a couple people here who will understand what I'm saying. The whole thing about chemistry happens in a shape like this, and you all recognize what this is. It's called a periodic table. And you have different areas. This area is for non-metals. This area is for metals. And usually the metals in this area are called transition metals. And the reason they're transition metals is because they change their oxidation state. Now the term oxidation state has to do with the idea that elements have charges. So you might have iron, or you might have iron with a 2+, or you might have iron with a 3+, and each of these act differently in biological systems because this is the metal, like you have on a cast iron skillet, and this is called ferrous iron, and it's in an intermediate oxidation state that it can be oxidized or reduced. So when you see this number, if it goes down, say from 2 to, no number here implied 0, that's a reduction, and if it goes up, it's an oxidation. This area here is for alkali metals.
Does that also change acid and base? Does acid and base change as well?
No, acid and base is a different concept that has to do with the elements in the table. That has more to do with hydrogen concentration.
So if you use acid or base test strips on it, the mean would be identical?
Depends on the pH, but yes. These species can exist at various different pHs. What we're talking about is the concept of pH, that if you have a beaker of water and you put an electrode in it, you get to measure the hydrogen ion concentration. That's an H+, and that's approximately equal to 7.2 in biological systems. And so when you have that sort of thing, that means that it's 10 to the minus 7.2 in hydrogen ion concentration, which means that 1 hydrogen ion in a million. But as it gets more basic, pH 10, 1 hydrogen ion in a billion. pH 13, 1 hydrogen ion in a whole mess. However, pH 1, lots and lots of hydrogen ions, way too many. But anyway, this is the alkali metals, and then you have alkali earth metals. And the difference between alkali metals, they all have a +1 charge, and alkali earths all have a +2 charge. Now, as you get over to these other non-metals, they have charges also. And some of the elements in this area are like carbon nitrogen, oxygen. You're familiar with those type of things. The most prevalent compound in the whole world, 99 out of every 100 molecules, is this one. And water is the major thing on everything on this planet, and that should be the ultimate focus of place where we can clean up and make a significant impact. But now let's talk about those chemtrails which spray out and then diffuse out. And by the fact that I was in the movie What in the World Are They Spraying with Michael Murphy back about 6-7 years ago, I became noted as the resident expert. And the three things we're really worried about are barium, strontium, and aluminum. And actually, the form that they are in the sprays are as the oxides. So we have barium oxide, strontium oxide, aluminum oxide, but notice aluminum oxide is Al2O3, and that's because the aluminum with its 3+ charge has to be balanced to the oxygen with its -2 charge. And so to get these balanced, that's why we need 2 aluminums and 3 oxygens. And this is called alumina, and that's one of the major components of what they're spraying. So why are these 3 the big bad guys? Let's talk about barium and strontium first. Well, actually, let's talk about barium and strontium first. Let's blow up this part of the periodic table that we had. And here you have sodium and potassium, lithium. You get barium and strontium down here. And so these are +1 guys, and these are +2 guys. Well, above the barium and strontium are things like calcium and magnesium. Now, we know that calcium and magnesium are very important to biological systems. And it turns out that the way the periodic table works is that when you're high in the periodic table towards the top of it, you're talking about small molecules, and as you get down lower, you're talking about bigger and bigger molecules. So lithium's a nice small molecule, sodium's a little bigger, potassium's bigger, and these all have 1+ charge. When you get to magnesium, magnesium with a 2+ charge is actually a little smaller. Well, you know what? Magnesium's on the wrong row because it's actually supposed to be on sodium's row. But it's 2+ charge. Magnesium is a smaller ion than sodium because being right next to the periodic table, you've got positive charges in the middle and electrons that are negative charges around the end. And to get these positive charges, you release electrons. If you've got 2+ charges, all the rest of the electrons are pulled tighter into that nucleus. So even though you think this is bigger, it's not, it's really smaller. And so what happens when they spray is that in biological systems, well, what's a biological system anyway? Everybody has okay?
I'm one.
You are one. In fact, every biological system is different, but it's usually made up of the same stuff. And the major component of a biological system is water. But the other part of biological systems is they got carbon-hydrogen compounds, and depending on what your carbon-hydrogen compound looks like, you can have all sorts of strange different structures on these different compounds, and we can put functional groups on the compounds. And when you get to the point where you're talking the biology of people like us, we've got things that are called proteins and enzymes, which are biological systems made up of lots of carbons and hydrogens and stuff like that. Well, it turns out that when you have these biological systems, like the one I drew over there, which is just a mock system, because you get a lot more carbons in biology. In fact, chemistry pretty much stops at molecules of 6, 8, 10, and organic chemistry runs on to bigger molecules, biochemistry even bigger molecules, in biology they forgot about the molecules. But something like this, if you take this hydrogen off, is a great place to stick the sodium. And the sodium attracts to the minus charge left by not having the hydrogen, and this is a form of a salt. And so you get these salts all over the body. Now, when we're talking about biological systems that involve calcium and magnesium, now we're talking about salts that are just a little bit more complex. And so you get things that look like this, which I'm drawing is called a porphyrin ring. And the porphyrin rings are elements that are specifically in the chlorophylls. Everybody knows what a chlorophyll is? It's the stuff that makes your plants green. And these have functional groups at different things so that every different carbon has 4 bonds, and every different hydrogen has 1 bond, and the nitrogens have 3 bonds, the oxygens have 2 bonds, but things are very specific. So the easy way to remember it is just think like a duck and honk. And if you honk 1, 2, 3, 4, that's the number of bonds you have to make between the elements. And so carbon has 3 hydrogens, and this carbon, that's its 4. This carbon gets bonded to this carbon and that carbon, and 2 hydrogens. This carbon is attached to this carbon, double bond to that, that counts as 2 bonds, and 1 to this oxygen, and this oxygen nominally gets the sodium to complete the set.
What
So,
about the
chemistry?
the nitrogen you mentioned? Is that part of the bond?
Yes, and the nitrogen, you can see how I have them with 2 bonds. That's because I didn't complete the structure of the ring, which actually runs around in something called conjugated form, and this is what makes it aromatic. And those are both chemistry terms that chemists like to throw out that have different meanings. Aromatic doesn't mean it smells good. It means it has a ring structure. But you know what? In chlorophyll, you have that magnesium that sits here, and it makes bonds with these nitrogens, and everything is copacetic. Now, magnesium is fairly small. Calcium is about the same size as potassium. Strontium is a little bigger than calcium, and barium is a little bigger than strontium. But you see, if we were to substitute a strontium in for this magnesium, and you know, that's what I think we're doing with the chemtrails, so we put strontium in it. Now, this is a bigger atom than was in it with the atom that belonged. And so, because of that, that's going to push this out of whack. This is going to have to be back here, and it's going to start breaking bonds and causing chemistry because you're putting a big molecule in place of something that was smaller, and everything has to spread out to accommodate it. The barium is even bigger than the strontium, and so now you can see when you get a barium into the lattice, first, it displaces a whole lot of things in the lattice. Second, it hangs on better so that you can't get it out of the lattice once it's there. So as where normal chemistry might have calcium substituting in for another calcium, and that'll work for a little while, and then another calcium will come in. Once a strontium or a barium comes into a porphyrin ring, it gets stuck. Now, yes?
Why Why are those getting substituted? What is it that's allowing, I mean, we're surrounded with all kinds of metals and chemicals all the time. Why are those getting sucked into the ring? Why is
Oh,
magnesium
this is an
replaced?
example of how the specific mechanism of a ring was only chosen because it's convenient to talk about. We could easily substitute it onto this molecule down here, in which case we'd have a calcium which is a lot bigger than a sodium, but here at least it's on the end of the molecule and can get swept off. The real problem with it is that, as I said, these things form as oxides, and they're stable in their charged form as oxides, and so when they stick to an oxygen, they think they're in their normal inorganic place. They're not really ready to go leaving the site they're at, and that's what holds them in, is the fact that the bigger molecules have a more finite attraction for the site than the smaller molecules do, and so the smaller molecules can't knock a bigger one out. Eventually that does happen.
Is that gravity?
Not necessarily. I think it a lot has to do with the size of the fit and the cavity that it's in and how much distortion it caused in a molecule. Because if you twist a molecule and it really is out of shape, the forces to put it back into shape are going to kick that off. But if you just make a subtle change and you make everything loose, what happens is that the components that get loose don't function as reliably, and so your mechanism for doing something like breathing and intaking oxygen might slow down because you've got things cluttering some of your sites because they wouldn't let loose like the molecule was supposed to. Now, for breathing and for transport, it turns out that the molecule that we're dealing with has a structure that looks like an iron sulfur cube. Somewhere in back here I'm missing something. Anyway, you get a cube structure, and the cube ends up attaching the oxygen to the sulfurs in such a way that it can break the bond of an oxygen atom. And it does that, it transports into the system, breaks this bond, substitutes it out for carbon dioxide, and then takes the carbon dioxide back out, and that's what you breathe out in your lungs. So if you get stuff in your lungs, as chemtrails are known to do, you can start hacking and building stuff up because you're irritating and not moving stuff out. And if anybody's noticed this last bunch of chemtrails that we've been getting, there have been a lot of respiratory problems associated with it. I think there's a lot more things than just these elements. I think that there's a possibility that they've got mold, fungus in it. Certainly the nanoparticles that they're doing, yes?
I think I started having trouble with my lungs in 1960.
Well, they were spraying back then too.
I lived not too far from George Air Force Base.
Yeah, a lot of this spraying started back after World War II. And the nominal thing is that it is a way of protecting the albedo of the earth. That by spraying these geoengineered chemicals in the sky, somehow it's going to increase the reflectivity of the earth, and so much heat won't come in and that. I don't know that I believe that explanation, but that's what they've been giving us. And it's a little strange. I tend to think that maybe what they're spraying is magnetic chaff, and that they want to change the vibrational frequencies that are out, because if it seems like this planet has a poisonous atmosphere, maybe the aliens will attack us. I don't know. Now, you get the idea of why barium and strontium at 2+ ions are hard on systems, because they're too big for the spaces they take up, and they're hard to remove. Aluminum is a whole nother story. Why are they spraying aluminum? Because Monsanto has a patent for aluminum-resistant seeds. What's with that? How does Monsanto get away with sticking a rider into an emergency spending bill in 2012 that says, you can't sue us if we find that the stuff we put into our glyphosate sprays is actually toxic to humans? Thanks Senator Blunt from Nebraska for that one. It's a pretty fascist world out there. I'm not sure that we can do much about it, but we certainly need to get them to stop spraying aluminum. Okay, who remembers what the charge on an aluminum ion was?
3 plus.
3 plus, yes. So here you have aluminum 3 plus. That's because it's in a different area of the periodic table, and to tell you the truth, what happens is that aluminum ditches 3 outside electrons because it's not really happy to keep them. When it ditches them, it gets this 3 plus state, and it likes to bond to oxygen. And remember, we said that we needed to have Al2O3. Somehow it all makes sense to get Al2O3, but not by that drawing. Anyway, somehow the 3 aluminums, in biological systems, we don't have many other 3 plus ions. They just don't really participate. Aluminum Aluminum's particularly nasty because it substitutes for magnesium and calcium also. But if you have a protein or enzyme, should I cover what proteins are? Let me do that. Everybody here probably remembers and has forgot what an amino acid is. But an amino acid has an NH2, a CH2, a CH with an R group, and a C double bond O, OH. So you have your amino side with a nitrogen, your acid side with a carboxylic acid, and you have a side chain, which can be something as simple as CH3 for alanine, or something as complex as CH2, CH2, SH for cysteine, or something with a Daffy ring structure like tryptophan, or several different other things. But in essence, what happens is the acid side of one amino acid condenses with the amine side of the next amino acid, and it makes a structure that has, well, let me draw it this way. That condenses a water out here and makes a bond so that these get bonded and you end up with a chain of amino acids, and these amino acids make up the proteins. The proteins are a component in our system basically found in meats that are not fats, which are lipids, but they are biomolecules, and they're basically the structural integrators of the whole thing. And so off these side chains you have various nitrogen groups, amines, you might have sulfurs, but when aluminum comes in and substitutes for a calcium that might be here, it brings a 3 plus charge instead of a 2 plus charge. And when it brings that 3 plus charge, well, everything in chemistry has to be charge balanced. And so not only does it substitute straight in for the magnesium or calcium, but somewhere else on the molecule, it kicks out either a potassium or a sodium, something that has 1 plus charge, but isn't needed because 3 plus and 0 is equal to 2 plus and 1. And so once you have potassium kicked off of a protein, it creates a hole. And in that hole, the rest of the structure grows to compensate to fill the hole. So when it fills the hole by compensation, everything's out of place. The protein is no longer as functional as it was when it was tight and working properly. And now it's gotten aluminum, which is not active in place of the magnesium that was, and a small hole, because it was a sodium or a potassium. But here's the real insidious thing. Aluminum is small enough an element that it crosses the blood-brain barrier without a problem. And so aluminum, by being in the spray in this form, goes through your blood-brain barrier, chooses a nice brain protein to lock onto, fixes there. Your brain says goodbye to a potassium ion. 1, okay. 10, not real good. 100, uh-oh. 1,000, 10,000. Now we're starting to see holes that look like Swiss cheese. Guess what? What do they describe Alzheimer's as?
Swiss cheese brain.
Swiss cheese brain. That's your cause of Alzheimer's right there, is the aluminum. It's also been implicated in mad cow, but to tell you the truth, the stories that I've heard about mad cow, I think, have to do more with magnesium than aluminum. Yes?
Duke just came out with his movie Rolling. And I think one of the things I was talking to you on the phone the other day, I was reading a book Dr. Russell Blaylock, top of the research and recommended on Candida. And the woman who wrote the book said on page 51 that the U.S. Senate Intelligence Committee had a special meeting in 2008 concerned with terrorists flying over America spreading molds that would kill millions of Americans. So her point was how deadly they were. Dave went in because his brain wasn't working. He would like stress on coming to tests, and he knew everything, but his brain wouldn't work. So he got a $3,000 brain scan. He was only like 30 at the time. His whole frontal lobes weren't working because of the mold. But you add mold, which causes all this inflammation in the body, and aluminum. And as we know, you can kill, with the amount of aluminum that killed one rat out of 100, the amount of mercury that killed one rat, you combine the two, where you add inflammation, everything gets far more toxic. So I think they're spreading not only molds, but all this aluminum and barium, and the two combined is just a powerhouse of taking out our short-term.
Now that you brought up the topic of mold, Lucretia.
This what? Say that again?
Now that Lucretia has brought up the topic of mold, I too suspect that they have mold in the sprays, but the mold that they have in the sprays is not enough to trigger the actual outbreak of things, but it does trigger immediately when exposed to Stachybotrys, which is a black mold, which is totally common around here with as damp as the Pacific Northwest is.
80% of homes? 80%?
I don't know if I think it's that high, but if you're dealing with a mold problem, the first thing you can do is to put some hydrogen peroxide into a spray bottle and spray down your mold, because that same oxidation chemistry that I talked about before, hydrogen peroxide is one of the better agents for starting oxidation reduction.
How about the
Because
nostrils?
I don't know yet. Let me think about that. But the hydrogen peroxide has the oxygen here as a -1 oxygen, and oxygen usually likes to be -2. These numbers mean it picks up electrons, but you always have to balance the charge in any compound you have. So when you use hydrogen peroxide, what you get is you get water and oxygen nominally, but normally if this oxygen is if the oxygen here, instead of making that oxygen is working to kill mold, you just get more water. So The idea is that I balance the chemistry equation here because whenever you have a chemistry equation, whatever's in your reactants have to end up in your products. And one of the best way to tell if a mechanism can work or not is if you can come up with an equation in chemistry that will let you know it might work. If there's no way to get to that equation in chemistry, you can probably guess that whatever you're talking about won't work.
So, hydrogen peroxide and saline, water?
I'm not even sure, well, the saline would work on a different mechanism on the mold.
Don't you combine it, like if you're doing mouthwash, you get a...
Oh, I was talking about spraying an apartment down.
No, I was talking about spraying up the nostrils, because Dave uses grapefruit seed extract, he used iodine, and he also used cortisone. He did 3 different sprays, 3 different times a day, so one...
Did they
I would think
all work differently?
Yeah,
Well,
that's why he hit his nostrils too, but his brain was gone.
actually, the hydrogen peroxide will work. You have to get food grade, and then you do there's actual standards for how you would dilute it for certain uses.
Yeah, it is.
But, yeah, you can get food grade hydrogen peroxide, and you can take it internally. It is an extreme oxidant, and it will help with some of the stuff that's we're absorbing in our bodies right now.
Is that the same as regular hydrogen peroxide you buy in a grocery
No,
store?
no, that has denaturants in it, and you should not take that internally. You could use it for what Dr. Lenny was
For what
talking about, but
I'm
not
talking about,
internally.
what you buy in the grocery store would work perfectly, but if you're going to use something in your body, you want to get a food grade or a medical grade just because they take more time to take other things out of it. Whereas what you buy in the store is technical grade, and they're not too worried about it because they make it in bulk and it's 99% in bulk. But what else is in it, it's like drinking alcohol when you're not buying it at a liquor store. Okay.
Same.
Just before you pass that, I've been here in Ashland for 10 years, and I've been dealing with black mold in a couple of places I've lived. I've been using regular bleach.
Bleach will work also.
I noticed that even though I use it straight and I don't wash it off, so it evaporates and just lingers whenever it can, it'll still grow back. It just keeps coming back no matter what I do to it. But I just keep punching
I
it
heard
back.
that bleach doesn't work. Try the hydrogen peroxide.
The bleach actually works, but it only works for a couple of months. It depends on the humidity.
So I'm wondering if the hydrogen peroxide will get rid of it.
Here's the thing, both of them have different oxidation states for the oxygen that makes them effective to work. And once they've worked immediately, they're done. They're not residual, they're not going to hang around. If you haven't solved the problem of what's generating the mold, it's just going to grow back. Now, I really question what is in these sprays, and we have enough evidence from various people, from indirect evidence, like when Francis Mengels went on to Mount Shasta and collected snowmelt samples that were 16,000 ppm in aluminum. We knew those were good numbers because he took precautions to go to a place that had no ground contact, fresh snowmelt, and no outside means of contamination. But you have to remember that the crust of the earth is 1.5% aluminum, and that any time you have a sample that hits the ground, the potential for contamination is there immediately. And so taking the sample is the most important part of the control in getting numbers to demonstrate things. But both Michael Murphy and Dane Wigington have approached people who have the power in the Congress or in the EPA or in some other agencies with undisputable evidence, and they slam the door on them and don't want to even address it. So the idea of collecting more evidence cannot be to just go to the courts and the politicians. But here's what I want to do. If we can get a little Radio Shack drone plane that can go up and fly one of these chemtrails behind the plane, maybe we can actually collect some direct evidence. And maybe we can even put a camera on the drone so that it can tell us whose plane it is. I've seen enough evidence presented that I'm totally convinced, but I think we're going to try for a Kickstarter or an Indiegogo on this sometime in the next couple months.
A good friend of mine is kind of a biggie with Boeing, and his last job was running the plant in Yokohama for him.
Okay.
And I kind of hit him up I saw the documentary about that one mechanic that had got called in to look at the sewer part of a plane and stumbled upon all this other piping and everything like that. And so I hit Dave up for that. I just, chatting him on the computer. He came back with like cookie cutter, well, Gary, what you're seeing in the skies is this new engine that they put out. I mean, it wasn't even Dave talking. And so I said, well, thanks, Dave. See ya. And so that kind of clued me into that. That's got to be what they're doing. It's commercial airplanes.
Yeah, we used to have a friend that works here out at the airport that we ran around with, and he just would not believe any amount of evidence that we brought to him.
I think that they know is what it is. Once they've been through that A&I, they're told, okay.
I think it's even more insidious than that. I'm not sure that half these people that work for government haven't already had their brain wiped.
There you go. Actually, very well.
It's really tough, but you know people and you've dealt with them for a long time, and then they get a government job, and within the next 3 years they're zombies rather than the people you knew.
Yes.
And so I'm pretty sure that in order to get a government job, you have to sell your soul to that guy Beelzebub with the red suit, make some deals that compromise your integrity. I also think that they've got something on all of us, and it's totally ridiculous that we live in any fear of them at all. We can create our own reality, and if we don't want these chemtrails to be sprayed over us, we need to take some action to let them know that we don't want chemtrails being sprayed over us. But is the chemtrails a higher order of business than, say, the GMOs? Right now, I have to think maybe chemtrails are more important than GMOs because Pandora's box is already open on GMOs, and we can't unmutagenate ourselves or the animals or the trees or that. Patricia?
Lenny, did you get natural news?
No.
Yeah, I did.
Mike Adams had an article with actual video. A scientist that has 600 different vaccines that they can release by air, water, or food. And the scientists were talking, they can take out a certain part of your brain. So if you're a fundamentalist Christian or Muslim, it's gone. You have no desire, you don't care about it. Or all of a sudden, like the police in Medford saying the suicide's up 18%. And just weird crimes, people just acting weird. So who knows if they are hitting us?
I've watched the police in Medford actually go out and shoot a guy. In 2012, when I was in Medford visiting for the holidays, was when they walked up, knocked on the door, and then said he was coming at it with a knife and popped him. And that was 3 days after there was another death by cop over at the Bluebird. So people who live around Medford know that there is definitely something wrong with the brains of the Medford police.
Can I
Yes.
throw in a little couple of tidbits? One is that you might be aware that anyone who wants to be a police officer has to pass a form of an IQ test. And anyone above, I think it was either 100 or 120, is not accepted. You have to be below a certain IQ level because they want people who are intelligent enough to
30
think,
years ago.
to do what they're told to do,
Yeah.
but not intelligent enough to go beyond the parameters they were given. You know, there's a lot of controls, and the reason I would agree with you regarding the geoengineering chemtrails being more severe than, let's say, vaccines or GMOs is because you can't avoid them. You can stop yourself from getting vaccines if you're not, a child and going to school. GMOs you can avoid to an extent, but you can't escape what we're being sprayed with.
Do you have a question in the back? Okay. What I'd suggest we do is take a 10-minute break. Then I'm going to have you come back here and I want to talk about a totally different problem here in Southern Oregon. There's an acid mine drainage problem at a place called the Formosa Mine up in Douglas County, just south of Riddle. And I want to give you a 20-minute update. And then I'll open to questions and anybody can ask me anything and I'll see if we can figure out the chemistry of what's going on with it.